Okay, welcome everyone. We're gonna go ahead and get started. Hopefully we'll have a few more people filtering in. Feel free, it doesn't look like we're gonna have too many people. So feel free to unmute yourself to ask a question, or you can just throw it in the chat and I'll get to it. So today's lecture is the OpenStudio parametric analysis tool. Before we get started, though, we'd like to introduce ourselves. We are the Integrated Design Lab. We are dedicated to the education, outreach, and technical support for high-performance, energy-efficient building design. This lecture is sponsored by Idaho Power. There are several other programs we offer. For instance, the Technical Design Assistance Program. There's 3 phases, all based off of a scope of work from under $2,000 to $2,000 to $4,000 to over $4,000. The phase 3 is a really in-depth, detailed design and recommendations along with reporting. That comes with a cost share agreement with 75% covered by Idaho Power and the other 25% covered by the owner. If you would like more information, feel free to email one of us or visit our website. We have the Building Simulations Users Group, and I just realized this slide is out of date. I apologize. It's a free lecture series that brings together architecture and engineering professionals focused on building simulation. The next one is on May 19th. It's with Dr. Damon Woods on weather normalization and climate design tools that he has helped develop over the years. And then we're off for a short break for the summer, and we'll be back in August, I believe the 24th, with automated 2D heat transferring in Grasshopper as the first topic. We also have the Energy Resource Library, and it's a free resource for Idaho Power customers. The library provides hundreds of free tools and guides to help experts and non-experts alike assess building systems or energy performance. I.e. Energy efficiency measures, if you're looking to identify those or see if you're getting, if they're performing as they should. So we have a wide range of tools from thermal cameras, data loggers, flow meters, light meters. This year, we added quite a bit to our indoor air quality section of tools with new ozone meter, new updated CO2 meters, differential pressure sensors, etc. So please feel free to check those out. You can visit our website to learn more. We do still have a contactless pickup drop-off system in place, though. I noticed Cherie is in the call, but she won't be chatting today. I don't know why this is like this, but please check out the Idaho Power Commercial and Industrial Energy System Efficiency Program. It's for retrofits as well. There was a recent update. They have a new program they're going to be rolling out. It was pushed back to June 15th. I also wanted to point out that the professional assistance incentive is doubled right now. And so that's not, it's in addition to the owner incentive, up to $5,000 per project. You can visit their website, idahopower.com/business to learn more. Without further ado, let's get into the lecture. My name is Dylan Agnes. I'm a research scientist here at the Integrated Design Lab, and I'm going to talk to you about parametrics and utilizing the parametric analysis tool. So parametric in its simplest form is relating to or expressed in terms of a parameter or parameters. In our industry, we kind of skip that step and we go straight to assuming the value of a parameter for the purpose of analysis. So you can think of it also as in scale. So, you know, you have a family, there's a chair, and you can apply a scale to it to change the characteristics of the model. It's not new though. Other industries are quite familiar and have been utilizing parametrics for quite a while. Most notably being in mathematics, science, and the financial services. Computing has also been using it. However, Not in the general sense of how we use our computing software. The other feature, which is where we come in, is a parametric feature-based modeler. So parametric design, generally when people think of parametric design, they think of something along the right, on the image on the right. It's a process based on, or the standard definition is, it's a process based on algorithmic thinking that enables the expression of parameters and rules that together define, encode, and clarify the relationship between design intent and design response. I kind of like to sum it up as a paradigm in design where the relationship between elements is used to manipulate and inform the design of complex geometry or structures. However, there are several types of parametric design. I'm just gonna focus on one, but kind of identify the two most common ones are the stylistic expression that you see on the right that I mentioned in the previous slide. The other more popular one that you probably know of is predictive behavior. So using parametrics to predict the behavior of buildings, that being building systems, structure, life cycle, occupancy, scheduling, etc. A few terms I want to distinguish because our industry in the architectural, engineering, and construction industry, we tend to take things from other industry and repurpose them without entirely changing the name or nomenclatures that come with it. So I just wanted to distinguish a few terms. An algorithm is a process or set of rules to be followed in calculations or other applications related to problem solving. A script is a list of commands that are executed by a certain program or engine, can be used to automate processes or generate web pages. And I'm referring to the computer science side of it, not movie scripts. They are very similar, but they have different intents. When I mention workflow or best practices, that's a common or widely accepted methodology of creating a model or a simulation setting for analysis. And so you can, one of the major forums or communities that's popped up for energy modeling is the Unmet Hours Forum. I believe it's now supported by IBIPSA. So I put a link there for their website. I encourage you all to become a member of Unmet Hours. It's very helpful. And then lastly, a measure is basically a script that can manipulate an OpenStudio model or associated data to apply energy conservation measures to either run additional simulations or process results. Now, looking into parametric analysis, there are two terms that mean the exact same thing that are being used by professionals. Energy conservation measure and energy efficiency measure. They mean the exact same thing. It's just some people prefer conservation and some people prefer efficiency. So I leave it up to you to decide which one you want to use. Some trends in our industry. Our softwares tend to have plugins. Plugins for us, as it relates to our industry, are basically tools that have been developed by the community of users of the software program, or they're used as a beta testing for software development companies to see if it's a feature they want to fully integrate later on down the road to the software. We like to have GUIs, which is graphic user interface, for our simulation engines. We've kind of realized that not a lot of people like working in the command line or just all text and numbers. We also have self-governing simulation tools. So instituting self-checks and balances within the program itself to help users. We like building templates, i.e. workflows and best practices to kind of get us started or let us know where we should be heading in the general direction. We like to build up our databases, and probably the two things that we use our programs for are uncertainty analysis and sensitivity analysis and optimization. The uncertainty analysis being posing what if questions. What if we change the window to wall ratio? What if we rotated the building 180 degrees? What's the impact that's going to have on the project? Sensitivity analysis and optimization you're probably more familiar with. That comes towards the end of the design stage where we're fine-tuning the HVAC load, sizing it correctly, trying to get the most efficient rate of return and well as energy use out of our systems, as well as identify those energy efficiency measures, making sure they're being implemented correctly into post-occupancy. So our industry goal is to have object-oriented abstraction for building energy modeling that simplifies the effort of creating models and related software applications. So parametric analysis. A parametric analysis or sensitivity analysis is the study of the influence of different geometric or physical parameters on both the solution of the problem. So a typical science example is the influence of the air gap length on the magnetic force in the contactor. We basically take that, the AEC industry, and we kind of repurpose that for buildings. So the influence of the air gap length in the wall family will have on the thermal loads, or the influence of the window to the wall ratio on the south facade will have on the thermal loads. Parametric analysis can be utilized throughout the entire design process, but it's going to be most impactful in the early design phase, such as the conceptual or the schematic design. It requires a significant amount of data to be available to perform at a higher standard. The further along in the design process you are, the less data is available. The reason for that is you've made decisions. You've decided what the window to the wall ratio is. You decided what your wall assembly is going to be. You decided the orientation or the programming layout of the building. So that data, that value or the parameter is set. And so you're not really looking to do what ifs or investigations on if we can change it. So here's kind of the typical design process that's kind of emerged in our industry. We have the pre-design to the schematic design. And then we start talking about, are we meeting certain target goals for, ASHRAE 90.1, LEED, those certain qualifications, are we doing it? And, we have the yes, you can move on, develop this further, refine, do another check to make sure we're optimizing it. If you get the no, then we're going back to schematic design. We're going to change some things out. What parametric analysis can allow you to do is to do this meet target, yes, no, internally in the pre-design and internally in the schematic design, and then having an overall meet target just to make sure you're still on the right track. So 2 things you should be using parametric analysis for: comparative analysis of design alternatives to identify optimal design parameters, and automating and modeling tasks or workflow steps that are common or repetitive. Anything outside of that, you're either getting into the research realm or you're kind of wasting time for what this tool is intended for. So modeling is an aspect of the design process that in recent decades has undergone rapid change, as well as adoption by multiple disciplines that help shape the built environment. Now, while a lot of people would like to say that this is the result of our industry heading towards the integrated design process, in my opinion, it overlooks the economic viability that each new model methodology has facilitated by either reducing time or money expended on a project through, say, cost estimation, decreasing the request for information or reworks, just getting more done efficiently ahead of time than when we usually would be able to do it. So on the right are kind of the big 3 that are known in our industry. We had CAD, that gave us layers, database, really increased work efficiency. Then we had, typical SketchUp, which is, the 3D modeling. So we're incorporating the Z-axis fully, and we can actually start to render, make, this fictional world resemble our real world. And then we have BIM, which is just another way of saying parametric modeling. We call it building information modeling in our industry. And it allows us a complete project database, integration of disciplines, and simulation and analysis. And the simulation analysis was started as exporting or plugging in certain programs to Revit or Autodesk Revit. has now been fully integrated into it. However, one problem our industry does have is formatting. And so the way that data is detailed, explained, and interpreted by software programs. One format that is emerging to kind of become the universal one that most software programs are heading towards is XML. You probably know it as initially as GB XML, which is Green Building Studio. So we're heading towards that way. Here's a list of programs and kind of where they are, if they're verified or not. And there's quite a bit more. That's the other thing about our industry is we have what seems like a limitless amount of software programs to help us with these tools. So hopefully we'll have the emergence of a universal standard that the software programs will adhere to. Then it won't matter how many software programs we have. But if you are interested in knowing about the software tools that are out there, you go to buildingenergysoftwaretools.com. It's a resource provided by BIPSA, which is just a directory of energy modeling. Well, not necessarily energy modeling, but just modeling software programs used in the industry. So using parameters to define a model, we see that commonly within our modeling when we deal with BIM in regards to dimensions, defining building characteristics, material density and properties, importing data. The biggest thing to note is that really made it useful for simulation analysis is that the parameter may be changed later and the model will be updated to reflect the changes. So that's a real key workflow development that helped with efficiency and bridging the, just the physical construction model with an energy model. So where are we modeling? So in the blank void where we model in our software programs, we have to know where we're going and where we are. We get that from the Cartesian coordinate system. That's one of them. SketchUp kind of made this popular. It was used before then, but SketchUp kind of made it more mainstream for our industry. And so basically, that lets you know where you are working in it. You don't generally see it in this way. You generally see this view on the right was what you're working in. But it's important to know this because from there we get a surface, and the surface is the Euclidean space, which is defined by a parametric equation with two parameters. So Euclidean space is the fundamental space of classic geometry, and it's basically used in Revit, SketchUp, Rhino, almost any 3D modeling program. They use it to different levels. Rhino is, in my opinion, the most extreme when it comes to this. But typically, we identify a family, which is a set of related objects whose differences depend on the chosen value for a set of parameters. Revit kind of took this and made it mainstream, as I'm sure you're probably familiar with. But so modeling, those are walls, windows, ceilings, floors, doors, etc. So our software model is a set of related mathematical equations that incorporates variable parameters. A scenario is defined by selecting a value for each parameter, i.e. site context, HVAC, lighting, schedules, material properties, control systems. And so the typical building energy modeling process is you have the architectural model, or you've been given plans, sections, elevations, what you need to make the 3D model. And you're putting it into a geometry software, i.e. SketchUp, to build the model. Then you're going to take it into a simulation engine, and you're going to, in this instance, we're going to be talking about OpenStudio, so OpenStudio. And then you're going to run the simulation, you're going to get the results, you're going to get some analysis that might cause you to go back, change some physical features of the model, or adjust some simulation settings on the model. And you're going to keep doing that until eventually we get the baseline and recommended parameters and changes to give back to the architect or designer. So OpenStudio itself is a cross-platform collection of software tools to support whole building energy modeling using Energy Plus and Radiance. It's an open source, so it's free. And it was designed that way to facilitate community development, extension, and eventually the private sector adoption, which is what we have been seeing the past couple of years. So NRail is no longer going to support the graphical user face for OpenStudio. They will continue to support the backend engine simulation, but that's kind of been taken over by a couple private individuals that have developed their own. So I encourage you to check those out. If not, you can always stay in the older version. I believe it's 2.9 would be the latest one you can go with using the SketchUp user interface, or I guess it's technically referred as the legacy SketchUp user interface, but yeah. So it's an API overlay for software engines and command line or text-based interface, particularly Energy Plus, API being applicable programming interface. OpenStudio allows building researchers and software developers to quickly get started through multiple entry levels, including access through C++, Ruby, and my mind is stuck on hashtag, sorry, C#. Users can leverage the Ruby interface to create OpenStudio measures that can be easily shared and applied to OpenStudio models. So I mentioned measures earlier. Again, measure is a script that can manipulate an OpenStudio model or associated data to apply an energy conservation measure. What that means is that it can either work directly in OpenStudio, or it can go to the back end of Energy Plus and make some edits as well that you wouldn't necessarily be able to do through the OpenStudio user interface. However, I will tell you right now, upfront, everything you need to know about writing measures or how measures work can be found in the software development kit documentation. It's a very good, in my opinion, it's very well documented reference for OpenStudio. Most of what I've taught myself about OpenStudio from 2.0 on is come from this type of documentation. And so there is a measure writing guide, which will literally tell you everything you need to know about writing measures. And so the other thing I should mention, nope. There we go. Other thing I should mention is the software development kit is basically all encompassing, getting you started, additional references for expanding more complicated things, and then just additional resources. So it's an overall guide to the OpenStudio software. Make that distinction. So documentation for a measure, because it is a script. So when you open it up in a text file, this is typically what you're going to find, as well as there are some information that is displayed within the program about the measure. So you're going to find the object for the measure and typical use cases, types of models it is expected to be used on, how to implement it, any additional information, warnings, or error messages that were reported by the measure, test cases that have or will be used to verify that the measure works. And so this was added, this tab. So this is the scroll paper down here. This is the measure section for it. It's divided up into 3 parts. So you have your OpenStudio measures, you have your Energy Plus measures, and you have your reporting measures. Reporting measures will allow you to manipulate the table data or visually display results. So if you don't want the Energy Plus tables, you want charts and graphs, and you can interact and export them. You want to do the default OpenStudio results. This was kind of the first major measure that they used to kind of push people to start looking into and using measures. Is the way you get your reports is by implementing that. There are several types. We have the envelope, electric lighting, equipment, people, HVAC. Refrigeration, service, water heating, on-site power generation is a relatively new one. Whole building, economics, and reporting. And each of these has subcategories that goes from one subcategory all the way to 8. And so you don't have to necessarily write every measure yourself. There is a library that you can use. It's called the Building Content Library. It's a comprehensive online searchable library of energy modeling, building blocks, and descriptive metadata. So that's their typical definition, but basically there's any user can access the library to download components or measures. And there's 2 ways to access it, either through the GUI of OpenStudio, or you can actually use a web browser and go to bcl.nrel.gov. Make an account, use the same account, I would recommend, or you can make a separate one if you want. But you can go there, you can view all the measures. In addition, there are 2 types of measures. They're public and private. So public is access to the library. Anyone can submit a measure or component for review to eventually be added and accepted. You have to become a developer to do that, but that is an option or avenue. The private version is anyone can create a group in the library, and that group has access to their own personal library. So you can upload and download measuring components to the group library, and it's only available to group members, i.e. people you specify. That exists because measures can give your firm or company an edge over another one in regards to workflow efficiency, as well as just expanded capacity of services offered through measure development. So that's why there's 2 types. You'll find in the OpenStudio program in the same measures tab in the bottom right hand corner, it says find measures on BLC or BCL. You just click that, bring that open. This menu, like I said, there's quite a bit of subcategories. So once you click on one, click on a subcategory, it's going to basically list the measures for you. And this right here will tell you how many measures are available. You check this box or multiple boxes, and you click download. Only in this menu interface would I recommend downloading multiple measures at once. If you're actually in the parametric analysis tool, I highly recommend doing it one at a time. It can get a little confused when you do multiple ones. When you click on a measure, it will give you some information provided by the author of the measure that will be populated here. Some measures have more, some have literally nothing. So use at your own will. So the measure will appear in your library on the right panel under the library ribbon. And so you'll have measures, and they'll break down all the categories we talked about. They'll be organized by their source, i.e. if they're going to go to OpenStudio, Energy Plus, or the reporting. So to apply it, you basically just drag and drop it, classic, I actually clicked it. Classic OpenStudio feature that's still there. And so it won't let you add, if I wanted to add OpenStudio results up here, it wouldn't let me. But you do that, and then you click on the actual measure itself, and this pane is then populated by the fields that you can input those measures, the variables that the author set up for those measurables. So let's get into the differences between using measures in OpenStudio versus parametric analysis tool. So OpenStudio, it's a single measure whose purpose is to modify a pre-existing model through physical simulation settings or building characteristic changes. The parametric analysis tool is intended to have a series of measures applied to an existing model, creating a scenario for analysis, evaluating the design alternatives to one another. So again, those resources I mentioned, again, really helpful, straightforward, step-by-step, will tell you how to write a measure. And you can also pull up a measure from the BCL and compare it and see if it followed this guide or not. And you can edit that measure itself to do more. In addition to there being a measure writing guide, there's also a PAT interface guide. Again, this is very helpful. It's still helpful, I should say. This guide is based off of 2.1 right now. So I know a lot of people are using 2.9, or if they've migrated to 3.0 and above, and in 3.0 and above, PAT is actually a separate entity to install. It doesn't come with OpenStudio anymore. So keep that in mind. So the parametric analysis tool allows you to quickly try out and compare manually specified combination of measures, optimize design, calibrate models, perform parametric sensitivity analysis, and much more. So it can be run locally by connecting to a separately provisioned instance of the OpenStudio server. Depending on the amount of data you're looking to perform, analysis will determine if you should use the cloud. And there's actually two separate features. There's a manual specified, as I said here. There's also an algorithmic mode. The algorithmic mode is if you're going to be doing simulations like over 50. So we're talking about you're getting into the couple hundreds of simulations, and that's definitely going to require you to use the cloud. Typically, you should be running anywhere from 5 simulations to 20 to 25. And that, depending on what your hardware is, you should be able to stay locally. You shouldn't have a problem with it, other than you may have to just get up, walk away from your computer for a little bit, let it do its thing, and you may not be able to do some background tasks on your computer as much. But again, that depends on your computer hardware. So real quick, I want to talk about parametric analysis tool versus Insight. The parametric analysis tool requires more user input and guidance, whereas Insight is based off of an assumption of inputs to provide users a range of inputs that they can select. So to give you an example of that. Oh, okay, hold on one second, sorry. There we go. So this is Green Building Studio. This is what runs in the background if you're using Insight for Revit. Oh, I didn't want to click that one, sorry. Hit this one. And so when you run an analysis or energy analysis in Insight, what it's doing is it's running all these different combinations. So you can see this is dealing with window wall ratio, window shades, glass types, etc. on the north facade. Just go down. Now we've gotten to the eastern walls. So there's about 248 different simulations run in the background by Green Building Studio. And so that's kind of getting into the parametric or the algorithmic mode of PAT. So the manual mode is kind of a more watered down, simplified version. In my opinion, is excellent to use in early design to perform what if questions. Later on, recommend just using the standard OpenStudio modeling process for optimization and sensitivity analysis. There we go. So this is what the parametric analysis tool is trying to do, is allow you to go seamlessly between the graphic user interface of editing the geometry to the simulation engine settings to running and processing results, being able to go in between those while allowing them to also still work in the typical fashion that we know. And so this is what the parametric analysis tool looks like. It's very similar to OpenStudio in that you have the ribbons or the icon on the left-hand side in a column, and that's kind of used to dictate the workflow that is recommended, just going one down to the next. You're going to spend most of your time though in the project home doing selecting the analysis mode, which is I recommend keeping it manual. Selecting your model, weather, and then setting the measures. So that's a big part. Design alternatives is the next one. That's getting up, setting up the simulation runs that you want to have. And then you have outputs for algorithm-based analysis. We're gonna skip that. It's typically empty unless you select algorithmic. We won't be going over that today. And then you have the run analysis. You can do it locally, or you can do a cloud service such as like Amazon Web Services. Then you have reports, and then we're also going to talk about the server. So add a measure, you click the add measure button. It's gonna, oh, by the way, sorry. Measures may be added in OpenStudio and imported via project library. So that measure is temporarily stored in the project directory of that OpenStudio file. So those will come in. Or you can directly add it in the parametric analysis tool. I recommend adding it in the parametric analysis tool. This will make sure that you're using the correct version of the measure. Another way you can do that is you can check for updates. That will pull up the measure menu and allow you to download updates for the measure. And you can choose to do that either just in this project or to your entire OpenStudio library. So when you click add a measure, measures will be automatically filtered to the appropriate section, i.e. if it's OpenStudio, Energy Plus, or reporting. The order of the measure matters, as that is how they're applied. So that hasn't changed. That carries over from OpenStudio. So make sure you're arranging them in the proper sequence that you want them to occur in or be applied. Now we're going to get into the demo. Oh, almost. Okay. So here's the parametric analysis tool. So if you're using Windows 2.9 or earlier, you're going to find it under OpenStudio. It's a separate one. If you're not, if you're using above 3, you're going to find it here in its own folder category. So again, keep it manual. For here, the default seed model, which is basically means what OpenStudio model do you want to use? It's gonna, so if you have the directory already set, it's gonna come up with a list. If not, it's gonna give you an option, navigate, select the appropriate model that you want to use. Next, important is the weather file. Make sure you're using typical weather file that you have used in your OpenStudio model. Again, you're going to navigate to wherever you have your weather file downloaded. Here, I'm just pulling a copy from another directory of a project. So we'll do that. And again, you can, once you have the directory set, if you have multiple weather files you want to try out, you can do that. Okay, so next we're going to go to add measure. So here you are. It's going to give you your filters by default are set to what's in your project file or your local directory. If you want to access measures beyond that, you simply click the BCL. And just for me, what I like to do is just unclick those 3 filters so that I know what I have and what I don't have. So I can just see the measures that I don't have added to the project if I need to update them. I can also look for Energy Plus as well as reporting measures. So make sure you specify the type. And down here, again, we're going to find our categories. That's carryover from the measure file development. So whole building tends to be the most useful. All right, turn that back on. Just because it's going to let you manipulate a lot of do broad strokes in regards to manipulating your model. So this one is rename spaces based on thermal zones. So you don't want to go in and rename all your spaces. You just want to have this do it. You can set the run period for objects that have been defined in the model, change building location, things like that. So not actually going to add it because I already have one added. So we're going to set lighting loads by lighting power density. And so you're going to basically just click on that and it'll give you the drop down. Click here, give you the description that is pulled from the measure file. And so what you're going to do is probably get rid of some of these. You're going to have an option. I'm sorry, the first thing you want to do is add measure option. So that's going to give you your options to select. And the arguments come that are basically what you would see populated in the right-hand side on OpenStudio. And so let's go ahead and add a couple. And so right now, so we have a couple options. They have the default values filled in. And basically what we want to do is check which ones that we're going to be editing. And so let's say, for example, we want to like reset everything because like for some reason we have all these selected. One thing you can do is, so option 1 is the alpha. So we hit that, then everything changes back. So this one, so 3, 2.5, 2, 1, and for editing numbers in here, I recommend highlighting and typing over it, because if you don't, you're going to get that, which is not quick at all. But then review the other arguments if you want to include them. So add lights to all spaces included in floor area, including spaces that did not originally include lights. So that's kind of making sure that you have lights everywhere. However, that could add lights in spaces you don't want, so we're going to leave that as false. If you have the material and installation costs for lights per floor area, you can input that value here, and it will calculate that for you. As well as if you have a demolition cost estimate, you can run that as well. Years until cost starts, demolition costs, expected life, things like that for this measure, but we're just worried about the LPD for now. And so model to base the inputs on. So if you want to change the model that you're using, you can do that here. But so so you want to set up all your options that you're going to be investigating. So here, we're 3 watts per square foot, 2.5, 2, and 1. Just kind of getting a range of what we're going to look for. So we can figure out what fixture type we want to use, whether that, the 2.5 to 3 being compact fluorescent T8s, and then the 2 to a 1 kind of being more in the LPD section. We might add an option over here to do a 0.7 or a 0.5 to get a look at that. And you always need to have, or at least I recommend, let's change our filters back. You need to have the OpenStudio results one. There are several other reporting results that you can look at. And the BCL has a wide range of reports that people have come up with. And you can take those and you can modify them to fit your needs, which is, we've done that with a few here at the lab. So you see a different one here. So we're going to hit OK because we already have it in there. I know this seems silly, but you do have to add an option for this one. And so here, this can save you some simulation time, depending on what you want it to process when it applies the measure for reporting out. Definitely recommend renaming it to either OS results or OpenStudio results, something simple like that you can remember. That's the other thing I did do up here. I just left them all as option 1 name because I want to have you see the default and how it all relates to each other. But I definitely recommend changing the option names and specifying what they do. So once you have all that, all your measures, all your options set that you want to investigate, we go down to the next tab, which is design alternatives. Let me get rid of this one. We can do it for all of them, of course. So there's a couple ways to add alternatives or design alternatives, which is basically the combination of measures that you want to apply. Or let's just go ahead and add one more so you can see. Sure, we'll add you, and let's say we want to replace the windows. So you hit OK. I'll bring this one out. We're going to have these guys. Add option to them real quick. And we're just going to leave the default options just to give you an idea. So when you come here, you'll see it's updated. So now we have our 4 measure options. So one of the things you can do is create one design alternative with each measure option. So you click that, and you'll notice that it basically created a matrix for you of all your options applied at least once. This is not entirely helpful right off the bat if you want to combine multiple measures to run together, because you'll see they're separated. So if you're running one measure, like say, for instance, you just want to deal with lighting loads by LPD and you want to investigate several different LPD values, then it's definitely helpful. But if you want to do multiple ones, it's a little more difficult. But for each one, by default, you want to have your OpenStudio results option selected so that you're going to get the results. And then this one, because we did the create one design alternatives, it's going to have that that name already populated for this one. But say we want to do that, you can go in and you can click drop down to add the options. And then say the other thing, you like an option, but you want to just change one measure value on it. Well, you make sure you have that clicked over here. So the whole row is highlighted, and you do duplicate alternative, and it's going to duplicate that. In addition, you can write change LPD to 2.0. And then you can add a further description. So say we have change LPD 2.0 and remove windows. So then we come over here and we add that. So now that's a scenario that we've created, or a design alternative, as parametric analysis tool likes to refer to it. And then so we can duplicate that and say, we don't want that one. We want to actually do the wall assembly. Input. Okay. Does anyone have any questions on this so far? I don't think I've seen any in the chat. But so this is kind of where I would recommend you kind of sit down with the design team, or if you're an architect, sit down with the engineer sit down with the architect, and talk about what standards you're going to be applying for, what you want to investigate, whether it's the window wall ratio, orientation, programming arrangement, also equipment, refrigeration, HVAC, whether you're doing DOAS, ground source heat pump, what are the things you would like to investigate, and just create a scenario of all those together that you can create. That's going to help you navigate this menu a lot better. But so say we're happy with this, we got everything working and organized the way we want. This is the outputs. So there are no outputs set in manual mode, so just skip that one. And now we have our run tab. And so first thing I want to show you about this tab is, so there's a way to open the BCL directly here under the window. Most of this is not really useful. You won't be using it except for the window one. You can open the BCL. You can set your measure directory. So if you're curious where it's pulling your measures from, you can change that, or learn the location pretty quick to add custom measures to it. But then server tools is most important. So when you start parametric analysis tool, you're probably going to see in the right-hand corner little gray dialog box saying local server is starting up. You need to have the server up to run an analysis locally. And so that's going to go off of your check mark here. So if you got the check mark, your server instance on your computer has been created. So now you can run. You can also ping server. So server is alive. Yay. You can also stop the local server. So you cannot close the parametric analysis tool until you have stopped your server, because it's a local instance running on your computer, and that has to be terminated before the program can close. And the other one is view local server. So if you click that, it will use your default web browser. Mine open on the other page. But you're going to find this. And it's going to basically, so localhost 8080, that's my port. So you can look at your projects, figure out, so these ones have been completed. You click on it again, and it's going to bring you a measure. It's going to give you all the alternatives you ran, start time, date time, what their status is, whether, so this deals with the status of the simulation. So the run has been completed. However, in this instance, there was a data point failure, so it did not work out. But it's still going to show up like that. So that's important. You can view it there, or you can view it in the results tab. So basically, you can either run selected. So once you start selecting things, you can have run selected, or you can run entire workflow. It's up to you. I'm just gonna do it. And here you'll notice you can't exactly type into this. It's a little counterintuitive. You have to have the lock symbol come up to unlock it, and then relock it, just so it knows the analysis. So, so it's also going to bring up any errors. So look here, detected. Oh, that's why it's not working. Okay, so it's having an output error. Yeah, I'm having a little bit of a problem. I got this to work last night before I went home. I came in this morning, moved my computer over to a private office so I give this presentation, and it decided it didn't want to work anymore. I have proof though. So I did this exact same scenario. We had a completed success, so it does work. I promise. There's some issues. I think probably what might be a few of the issues is that I have this setting check. Yeah, I run into a few more issues because I have 2.9, 2.91, and 3.2 installed. I work on several different versions of OpenStudio. Like this. But I just want to show you what it looks like when it's running, so you can see when it's not going to be, or when you're going to get a potential error from it. So we do that again. So if your server status isn't checked, you can start it, but what it's going to say instead is starting local server. Then it's going to go analysis run, and I like to this point then bring out the local server, because that will. There we go. So now it tells you the current analysis that I'm running, well as the other ones that were already previously run. You click into it. It's going to give you, so you can basically have this open and check this instead of waiting for this progress bar. So either one's your preference, if you're going to have this open still working, or if you want to have the other page open and working. But once you do that, so another thing to notice is it's not going to let you leave. So you have to wait for it to be complete before leaving the tab. So you're not going to be able to do everything else. So I guess I'll take some questions at this point. I plan on recording, or I guess re-recording this part of the presentation when I get my model to cooperate with me. Currently, it's not wanting to do that. But basically, you would come to here. You get several different options for comparing your data right off the bat. You'll have a list of all your alternatives here. You can set one to be the baseline, and that will do a comparison between each of the columns here. So you can see the difference between each simulation, measure variable scenario that you've applied. So i.e. if the LPD is 3 versus 2 versus 1 versus a 0.8 or a 0.7. which is typically what LBDs or LEDs can come in and around. So, and again, this is the server. I like to bring it out in the HTML page just because you're not really able to access that quite yet when you're running the simulation. So it'll give you a little more information ahead of time. But typically, if you're running your sim and you see it and the status doesn't change and it's saying starting up and it just says NA, then you likely have a compatibility issue with your OpenStudio results measure, which is why it's not running properly. So that's all I have for you guys. Like I said, I'll be re-recording this part of the lecture when I successfully get my model to run again. Then I'll be going over, I'll just edit the video to add the part in to where I'll go over this section in more depth and in detail, because this is probably the most important part in my opinion. Once you get this, because this will help you advocate for certain design decisions to a client, or at least allow a more constructive conversation to occur between the engineer and the architect about why certain decisions need to be made. Yeah. Also, there's a poll that was just launched. If you could please fill that out, we would appreciate it. Thank you all for attending today.